I want to provide an example of what I mean by different representations. So I've listed 6 standard representations: verbal, pictorial, schematic, tabular, graphical, mathematical. So here's a verbal representation, and by verbal I mean either written or spoken. Alice walks 20 meters at a speed of 10 meters per second in 2 seconds. She stops for 3 seconds to pick up a book, and then walks back 20 meters at a speed of 5 meters per second in 4 seconds. So that's a verbal representation of an event. The next step will be a pictorial representation. A pictorial representation could be a picture, a drawing, graphics, or even a movie. So a pictorial representation of this, I'll draw a picture. I have Alice, who's a person, who's walking along. 20 meters away is a book. Alice walks there pretty quickly to start, stops for 3 seconds, picks up a book, so that's going that way, but then turns around and walks back at a much slower pace, well, a slower pace, the same distance at a speed of 5 meters per second in 4 seconds. So here's a pretty bad picture of that event, but a picture is terribly important in visualization, which will greatly help you solve problems. A schematic representation is different from a pictorial representation in that I'm not trying to get a picture or a visualization of what's happening, but I'm trying to represent the system in a way that I can translate it into math. Here, I'm going to represent my objects here as points. So this point will be Alice. Here's another point. This will be the book. These are 20 meters apart. And now I'm going to add a coordinate system. Coordinate system has a 0. I'll put the 0 of my coordinate system at Alice. I have a positive direction and a variable for the position along the coordinate system, which I'll call x. And now I know the book is at 20 meters. I have my objects represented by points here, and I have a coordinate system on my picture from which I can make measurements. With a tabular representation, I start to quantify, so I've included my schematic representation here to help me. Alice walks 20 meters at a speed of 10 meters per second in 2 seconds. So I have a table where I'm going to quantify the position of Alice as a function of time. Initially, Alice is at the position 0. So at time is equal to 0, where it starts, the position is also 0. She walks 20 meters at 10 meters per second in 2 seconds. In 1 second, she will have moved 10 meters, so 1 second later she'll be at a position of 10. 2 seconds, she's at a position of 20. She stops for 3 seconds to pick up a book. So for 3 seconds, second 3, second 4, and second 5, she will be at the same location where she picks up the book. Now she walks back the same 20 meters, but now at a speed of 5 meters per second. So a second later, she'll be back at a location of 15, then another second she'll be back at a location of 10, another second be back at a location of 5, and then at 9 seconds after the start, she'll be back to the location of the origin. So this is using a schematic representation to translate a verbal representation into a tabular representation. Now I'm going to create a graphical representation. I've included my tabular representation here to help me. The vertical axis is x, which is position. The horizontal axis is time in seconds. 0 seconds, she's at the origin. But at 1 second, she's at a position of 10, and at 2 seconds, a position of 20, where she stays for seconds 3, 4, and 5. At 6, comes back to a position of 15, 7, 10, 8, 5, and 9 back to 0. So these are straight lines, and so I could sort of draw the lines in, and I now have a graphical representation of the system. Finally, I want to have a mathematical representation. A mathematical representation means I'm going to have equations that represent my motion in this case. I have 3 regions of time where the motion is straight lines, so let's split up those regions. The first region is the time between 0 and 2 seconds. Then I have the region 2 to 5 seconds. And then I have 5 to 9 seconds. In the first region, I might have to do a little bit of calculation on my scratch paper, but I eventually can figure out that the position as a function of time is equal to the number 10 times the number of seconds. 1 second it's a value of 10, and at 2 seconds it's a value of 20. The position as a function of time in this middle region is just 20. And now for the last one, I might have to do a little bit of calculation there as well. But once I do, I find that this is 45 minus 5t. And you might wonder how I figured that out. And I know it's a line, and I can tell the slope of that line, which is -5, and then it'll be some y-intercept b, and maybe I don't know what that is. But I do know at t is equal to 9 seconds, the value has to be 0. 0 is equal to -45 plus b, so that tells me that b is 45. So my third region is given by this expression, and so now I have a complete mathematical representation of the motion.